Now, hello. Hello, everyone. Can you hear? Interesting. There. I don't think it was my internet connection at home, but I've been having problems streaming on OBS. All of a sudden, it seems like the key got messed up or anything. Okay. Hello, Hacksaw 1337. Can you hear? Audio quality good. Video quality good. Hello. Any good? Hello, Gabman. Hello. Hello. Okay, quality is good. Okay, so it seems like we're good now. Um, yeah, I got sorry for the delay start. There was definitely a little bit of a problem getting started for today. So okay, looks like that is still going. So I had trouble actually getting started. Anyway, so hello everyone. Welcome to Introduction to Security. I'm Ming Zhao, Associate Teaching Professor at Tufts University. Believe it or not, today's the second to last Twitch stream of the spring 2021 semester at Tufts. This is the second to last. Next Thursday will be the last session I will do for the spring 2021 semester. It will be a promise. It will be a blow up bash next Thursday. I like to end the class with fireworks and sobering remarks. So next Thursday, April 29th, will be the last session for spring 2021. Will it return in the fall? To be determined. We don't know. We don't know if Twitch will be back for fall 2021. It would be nice to be back because I actually enjoy doing these Twitch sessions. So today we're going to do forensics and incident handling. And a lot of today, I'm going to speak from personal experience because I used to do some work with law enforcement. Yeah, I used to do some work with law enforcement, and you learn quite a lot about the forensics process and and also incident handling. But I want to give you a little bit of motivation first. And why in the world is forensics and incident handling talked about at the end of this course? Now, the course website is comp116.org. That's the Introduction to Security course website. But do you all remember the first lab that was due at that would that we did on the in February? The very first lab that we did for the class, and if you're not familiar in my security class, the first lab is always on working with the command line. And the working with the command line, I need students, especially who are taking this class, to be familiar with a whole slew of commands on the command line, like ls, rm, cat, the list goes on. Is that necessary? Is that you're going to see that later today? And the answer is yes. You're going to see that again. But there's a question that I ask about. I want to enlarge this is what command can you use to securely delete a file? Remember that question? What command can you use to securely delete a file? So I want to ask, what command can you use to securely delete a file? If you remember. There's many different, there's a whole list of options. Anyone know? What command can you use to securely delete a file? That also means that you should not be able to recover a file after. Yeah. Okay. So. Okay. So I'm starting to see a couple of answers here. The best answer, if not one of the best answers, is shred. Shred is a command to securely remove a file. So I'm going to load up Kali Linux. I'm going to log in here. Oops. So I'm going to open up a terminal here, and I'm going to do man shred. Shred, overwrite a file to its content and optionally delete it. And the description is, the specifier overwrite the specified file repeatedly in order to make it harder for even very expensive hardware probing to recover its data. And this is what I mean by securely removing a file. So you don't want to recover, you want to delete a file so you can't recover it. There's another reason why I asked this question. What command can you use to securely delete a file? It's actually a slime ball trick to prepare for today, which is if your answer for the question, what command can you use to securely delete a file, is rm, then it's wrong. Like, I want to put you into that trap. So if you put rm minus capital P file name, that could potentially work as well. I'm fine with that one. So if you do man rm to remove files or directories. Now, what is rm minus capital P? I don't know if they have it here. Do they have it here? No, they don't have it here. There are so many different versions of rm, but there is a rm with a capital P option that is quote unquote a little bit more secure. But if you're just trying to remove a file with just straight rm with no flags, that file can always be recoverable. And that's what we're going to do today, is how can we recover files that were just deleted with straight rm? Not using shred, not using rm minus capital P, but how do we recover files that were removed by straight rm? And this is proof that when you delete a file with rm, it doesn't really delete the file. You can always recover it. And we're going to do a live example of that today. But before we actually get into the live demonstration, what is important that we need to do is to get some of the basics right, which is going to be a lot of the definitions. So bear with me. In that we're going to cover some of the important terminology first. So what we're going to do today is how do you acquire data from a disk using DD. We're going to analyze a disk image. This is what we're going to do. This is going to be the live demonstration. That's like, how do we analyze an image of a disk using DD using forensics tools? So we're going to use Autopsy and Sleuth Kit, and we're also going to use Foremost as well too. And ultimately, yes, we're going to recover deleted files off a disk. Okay. So a nice scenario is, imagine if you have an attack compromiser is involved in a criminal incident. What's the evidence? What happened? Who was involved in all that? So the what, when, who are questions that are important. That's the whole point of forensics. So forensics is to answer all those questions. Basically, it's like a crime scene. Who done it? What happened? So in addition to answering those questions, what forensics really boils down to is 5 things. The preservation of computer media, the identification of computer media mean file, content, whatever, the extraction of the media, interpretation of the findings, and most importantly, documentation. Because chances are, if you're doing forensics work, your work is going to be grilled in the court of law. And so documentation, you better make sure there's no stones unturned. The process of forensics are assess the situation, make notes, acquire the data, analyze the data, write your report. Okay, so today we're going to do mostly the acquire and analyzing of data. More so with the analyzing, not so much with acquisition, because that could take a long time depending on how big a disk is. Now, hey Chris, how are you? Thanks for tuning in. So, before you do anything, before you go into any crime scene, before you start taking out, USB drive for analysts, before you take out a hard disk or anything, what you got to do if you're in law enforcement is, you have to obtain a search warrant. And I'm going to show you a few screens of how it is, like what an application to find a search warrant looks like in the trial court of Massachusetts. Okay, and it's just 2 pages. It's a front and back, and then you get a sign off, and that's an example of a search warrant. And this is an example of a search warrant. Get a warrant before you do anything. You got to do that first. Here's another example of a search warrant. Get the warrant. Okay, terminology. Basic info. You gotta know these. You gotta know these terms, and especially when you do forensics. Volatile data is any data that changes over time. This includes RAM, memory, and running processes on a computer. Non-volatile data is something that really becomes like quote unquote stagnant. Think of hard disk and USB drives. Look, the content of memory is going to change all the time. The content of processes are going to change all the time. Hard disk, USB drive, they're the hardware. Okay, they're the big things that you can make copies of. Now, there are two types of data acquisition that you can do. The first option is do a physical acquisition, which is a bit-by-bit copy of the entire physical store, which will mean hard drive. Do a bit-by-bit copy of a hard disk or a USB drive, or more commonly these days, which is becoming a big issue, phone. Now, a phone would be a non-volatile data. Now, there's also logical acquisition, that instead of doing a bit-by-bit copy of the entire physical store, you do a bit-by-bit copy of directories, files on a file system partition. For example, if you don't want to do a bit-by-bit copy of the entire Android device, you only want to take a logical acquisition of, maybe one or two directories on Android. So what's the difference? So can anyone know the cost differences of physical and versus logical acquisition? Anyone want to chime in? What do you think is the cost of physical versus logical acquisition? Pros and cons. Anyone want to chime in? I can tell you right now, physical acquisition, you're going to do a bit-by-bit copy of an entire physical store, maybe let's say a 40 gigabyte hard drive. It could take a long time. Yeah, and that's it. Physical is much more longer, but it's more thorough. Logical is a lot faster, by a lot. But is it as thorough? Yeah, if you make the mistake and copy the wrong directory and file for analysis, you got a problem. Okay? So one of the big problems with physical acquisition, it's kind of hard. It's going to be hard unless we have okay, back in the days, there were 256 megabyte USB drive. Those things are great for like a live session like today, because 256 megabytes is like nothing these days. Back then it was a lot, like in 2007, 2008. Now, I mean, what's the average, what's the starting size of a disk? I mean, we're talking like gigabytes, and like 16 gigabyte, 8 gigabytes, far cry. So nowadays, to do a bit-by-bit copy of a 256 megabyte hard drive, easy peasy. But that number has gone up so much in terms of space. Now we're looking at the gigabytes. It can take hours. I think it was what is it, 16 gigabyte, a 4 gigabyte SD card. To make a copy of that is like a good 30 minutes, which we're not going to do on the air. We're not going to do. There are also the devices, these hardware devices called write blockers. That the whole point of a write blocker is to acquire information on a drive, but there is absolutely no possibility of damaging the drive content. There's absolutely no writing at all. You're only reading from a drive, not writing. They do this by allowing read comments to pass, but not blocking command. I'll show you a picture of a write blocker. These are not cheap, but important in forensics. A write blocker looks like this. There are these little here we go. These are some examples of write blockers. These devices, you can make copies of disk. There's absolutely no writing to the disk at all, only reading. So it blocks any possibility of sending data onto your disk, which can corrupt the evidence. Here's another write blocker. So here's a hard disk, plug it in with the cable, and this actually goes to some collection or something. Name like maybe, is that a power? No, that's power. So it's making a copy of this somewhere and somehow. Okay. There's a way that you can actually stop putting stuff onto a disk, really helps. A quality one will also make sure you can copy one, yeah, as fast as possible. Really important if you're on a crime scene and time is sensitive, is really sensitive. Here's a kit. They're like hundreds of dollars. If you're going to do this professionally. Chain of custody, chronological documentation, cradle to grave, warrant, seizure, custody, control, transfer, analysis, disposal, like the whole process from start to finish of an incident. Yeah. Hey, Mr. Bill. So, of course, what could possibly go wrong if you actually don't use the right blocker to acquire the evidence data? Think of, like, that's a fun question. Like, what if you don't use the right blocker if you to acquire evidence or data? Here's a good question. Here's another thing to ponder on a side too. What if your disk is actually riddled with like ransomware or or with malware? Oh, and of course, what are the pros and cons of physical versus logical acquisition when you want to use one over the other? We just did that. Okay. Think about things to ponder. All right, forensics tools. What are your tools that you got? Well, and this is one of the reasons why on the very first lab of my security course, it's a lab on command line tools. Like the real bread, like the real quintessential forensics tool sat up at the very bottom. And you've seen some of these before. And I know a lot of you are familiar with them. Strings, okay? Strings, find all the human readable strings in a file. MD5, SHA-1, SHA-256, SHA-5, the hashing. Hashing, absolutely critical. Because remember the CIA triad, confidentiality, integrity, availability. The integrity. You want to make it, in terms of forensics, maintaining the integrity of evidence is critical. FTK, there is NCASE, which is like the de facto standard these days by law enforcement departments. By NCASE forensic software, computer and mobile data acquisition interface, processing external view, investigation workflow. It really is the gold standard. It really is. I remembered when I was first getting involved in, I want to give a shout out to the High Tech Crimes Investigation Association, which I used to be a member of. I was a member in the early 2000s, and it really set up my network. It really is, but it's not cheap at all. Triage, collect, really nice commercial software. I want to give a shout out to, haven't been a member for a long time. I'm in bad standing because I haven't paid my dues for all these years. So if you're looking for an organization that does this for a living, the High Tech Crime Investigation Association, they do a lot of stuff, a lot of talks on forensics. It's not just law enforcement, but also places like investment companies are also members of this as well too. Education of the Boston chapter is a lot of fun. I want to give a shout out to the HTCIA because they really helped me with my career earlier on. Okay. I think some of you folks may remember this tool called Steg Detect in the Capture the Flag game to detect any sort of steganography, which is data embedded inside of pictures and other files. But I did not mention anything about DD, Salute Kit and Autopsy, and Foremost. I did not mention all of those because that's what we're going to do today. And they're absolutely fun to use. All three of these tools, DD, Salute Kit and Autopsy, and Foremost, are all on Kali Linux. And so there is a nice forensic suite in Kali Linux that you can play around with. So it's time to do the demo because you already got all of the tools that, you know, you already have like a lot of the basic background information. I do only have a few more slides after this, but it has to do with the difference between forensics and incident handling. But you've been seeing the two letters DD a bit so far. So what in the world is that? What in the world is DD? So here's a fun computer fact for you. If you have, for example, like, maybe I'll do this on the Mac OS first. I'll do this on Mac OS. So here I am, here's my Mac. No, it is not. This is where the fun fact becomes. DD is close. This is one of those fun things. DD stands for, are you ready for this? Here's a fun fact. DD stands for convert and copy. Yeah, DD stands for convert and copy. You're like, what the hell? What? Convert and copy? Yeah. DD stands for convert and copy. I kid you not. Man, DD. I'm on my Mac OS right now. DD stands for convert and copy a file. Yeah. DD is a utility that copies a standard block input to standard output. If DD input data is written from 512 byte, it'll block the short, yada, yada, yada. Wait a minute. You're like, what? That's messed up. And yeah, it is. It is messed up for a reason. But hear me out and why that's the case. So DD actually stands for convert and copy. But we're just like, wait a minute. Convert and copy is CC, not DD. Right. Well, here's the problem. Back in the heydays, back in the 70s when they were developing Unix, how did people type? They type with two fingers. And they would do things like DD, CD. I mean, that's the reason why a lot of the Unix commands are two characters. Because people usually type with two fingers. LS, CD, RM, MV, you name it. But what about CC and DD? Well, here's the problem. CC was already taken. CC is a C compiler. So they couldn't use CC for convert and copy. So they had to go a step up, which was DD. It's messed up, but yeah, that's the brief, really interesting history. That's a really interesting history of it. Now, I'm going to show you how to use DD. Hold on for a second. I need to go downstairs and get a USB stick. Hold on. What am I meant to go for? All right, here I am. All right, I'm back. So here is a SanDisk Ultra USB 3.0 64 gigabyte USB stick right here. It's blank and empty. All right, so I'm gonna quit. On Mac OS, there is a way to take a look at all the disks that are available on your Mac. It is disk util. This is Mac only. Disk util. Mac OS have a tool called disk util. Most of the commands require an administrator or root user. You can list out a disk, get info on a disk, eject a disk, unmount a disk, verify a disk, repair a disk, erase a disk, secure erase a disk, you name it. Okay, so disutil is a tool for Mac OS only to do a whole bunch of disk operations. Why am I bringing this up? Because I want to do a list operation. Disutil list. And as you can see, here I am right now. I have a whole bunch of disk lists, here. /dev/disk3 is my entire disk. It's a solid state drive on my Mac, which has a whole bunch of different partitions. Disk 3S1, disk 3S3, S3S1, whole bunch of these things. Whole bunch of disks. Now, one thing I will do right now is to plug in this USB stick. I'm going to plug it into my Mac. And watch what happens. So I got a personal disk here. Got nothing on here. 61.49 gigabytes available. Now, if I go to disk util list again, now you actually see a whole bunch of disk lists. Actually, you see a whole bunch of disks, but this is brand new. /dev/disk4, external physical. /dev/disk4 is the entire is the command line name for the disk. NTFS formatted. Yep. Indeed. Now, let's say you want to make, let's say you want to do, you go back to definitions, a physical acquisition, bit-by-bit copy of the entire physical store. If you want to do a logical acquisition of the entire disk, in this case, the USB stick, the 61.5 gigabits of the entire USB stick, you go to somewhere like your desktop, and you would do sudo dd if equals blah, of equals blah. At the very simplest form is sudo dd if equals something, of equals something. If stands for in file, the input file. So if you want to do a bit-by-bit copy of the entire USB stick, you would do sudo dd equals, sudo space dd if equals /dev/disk4. Out file, of equals output. And for the extension, you can do something like .dd or .img, .iso, doesn't matter. Okay, and then I hit enter. So what this will do is sudo space dd space if equals /dev/disk4 space of equals output.dd is going to make a bit-by-bit copy of the USB stick that I just put in, and it's going to create and store all that output to a file called output.dd. And if you can imagine, output.dd is going to be 61.5 gigabytes. It's going to be match exactly the size of the USB stick. So all you have to do is hit enter. And as you can see, my desktop is starting to make a bit-by-bit copy of the USB stick that I just punched in. And this thing is going to get really big, really fast. Okay? How long will it take to do a bit-by-bit copy of the USB stick? In this case, it will probably take at least 30 minutes. Now, I'm going to stop here. Like, we're not going to do that. And it's going to take a lot of time. Now, here's the one problem with DD. DD, of course, what it doesn't do is it doesn't show you any progress. The only progress that you will see is at the end when it finished copying the entire disk. That could take 30 minutes to hours for something to show up if you run DD. DD by itself, if you just do DD IF in file equals whatever OF equals output.d, it's going to be slow. Okay? Can you get a verbose? Ah, that's a great question. Can you get a verbose? Yeah. Man DD. There is a verbose mode. There should be. I think it's minus V. Come on. Okay. You had to ask this damn question about the verbose mode, which is great. Okay. That question. You had to ask Gab, man. You really had to ask this question because here it is. It's a great question. It's a gold star question because it's been asked before. If you wanted, yeah, I mean, it's a pain in the ass. So this is, of course, yeah. You can also, yeah, you can also get the kill. Yeah, I mean, you can do. But now it's funny that you had to bring this topic up because this is one of the big problems with DD. Also, what happens if you decide if your disk is corrupted? So DD doesn't deal with that kind of well. Okay, so the question that Gaman posed about if you get a verbose mode of a DD is one of those quintessential ugly questions. It's one of those really ugly questions and one of those problems that is not in DD. Fortunately, there have been organizations that have made variants of DD. You may have heard of one called the Department of Defense in the United States. So I want to go to my personal website, and this is really for Gab, man, because you had to ask that question. So I gave a talk to the HTCIA way the hell back when. The hell is it? Ah, here it is. No, this one, Investigations and Incident Response Using Backtrack. I made this presentation in 2009. I'll put a link to this. This is a 2009 presentation, but because Gabman had to bring up this question of verbose mode of DD. Now, FYI, Backtrack is now known as Kali Linux. Where the hell is it? I'm going to need to... Here it is. Here is one version of DD with verbose mode. This is dcfldd. It is created by the Defense Cyber Forensics Lab at the Department of Defense. And one of the shortcomings, as you mentioned, is verbose mode. What dcfldd does is does hashing on the fly. So calculate the MD5 checksum while it's being copied, has a status bar, and yes, you can also use it to wipe disk. That's the first tool. The other one is DD_rescue, because DD doesn't rescue bad sectors of a hard disk. That's another one. I'll come to foremost back later on. Yeah, I do want to remove that. Let me go back. Do I have the terminal screen of Kali? Yep, I do. Oh yeah. Sudo apt install dcfldd. Is it part of Kali? Yeah. An enhanced, so on Kali Linux, dcfldd is an enhanced version of DD for forensics for security. There you go. Ah, here it is. Let me just, hold on. Here we go. So this is for Gabman. Yep, hashing on the fly, data integrity, and of course status output, which is verbose mode. There you go. Yeah. So dcfldd is what you want to use, not regular DD. Yeah. I don't know if it's being maintained anymore, but hey, that's another thing. There's also another thing about the dd command that is important, because if you just do dd if input file and of output file, it's slow as hell. So by default, it's only going to read input data is read and written in 512 byte blocks. If you want to speed it up, use a BS flag. BS equals N, where N is the number of bytes. So I actually always do like 5 megabytes instead of 512, but the default 512 bytes blocks. It will really speed it up. The biggest problem is if the bigger BS value that you put in, you really risk not copying everything. But if you want to speed it up, I mean, think about it this way. What the BS option feels like, if you're ever cooking and you use a spatula and you try to speed up like the cooking of meat, feels like that. Having command line tool tell me that it's still working, it's quite so pretty neat. Yeah. So when I copy a disk, I use BS. All right. I don't need this anymore. But now you know how to copy a disk. Now, what I am going to do now is I'm going to post a real example of a disk that I want you all to analyze. So we're going to do an exercise right now. Here's a link. I want you to download. This is a 47.7 megabyte disk. I'm going to save this to my desktop. Here's an exercise that we're going to do. And you can follow along. Evidence.dmg. Okay. Now I don't need the USB stick anymore, so I'll take that out. But this is a DMG file, which was a result of DD. So I made a copy of it. It's a 50 megabyte. 50 megabytes. Evidence.dmg file. And let's play around with this now. So the first thing that you always want to do is calculate the checksum of a disk. You gotta do that. And the reason why you want to do that is if the file is going to be used on multiple systems by multiple people, you need to make sure that the integrity of a file is intact and that it hasn't been tampered with. So I want to calculate the MD5 checksum of the file I just downloaded. I just provide the link in the chat. And it doesn't matter. It doesn't matter. Don't worry about that yet. If you got Windows, don't worry about it. Don't worry about it. If you got Windows, don't. So I'm going to do an MD5 sum of evidence.dmg. And here is the MD5 checksum of the file that we have just downloaded, evidence.dmg. The only thing I will show you which is relevant for the Mac is what is on the disk right now. So if I double click on it, I get this evidence, but it only got two things on here. One's a text file and one is a picture. I got one of two files selected, 47.9 megabytes available. There's only two files that you can see visible. But the question is, are there any other files on this disk, namely that they got deleted by RM or deleted some other way? So if you try to open up the file, go for it. Let's take a look at what this picture is. Okay, fine. Thank you, Bikini Bottom Twitter on Reddit. Okay. There's only two files visible on this disk. But are there more? Are there stuff that got deleted off of this evidence file? And that's what we're going to find out. I don't need this anymore. I'm not going to use the Mac anymore. I don't care if you got Windows, Linux, whatever now. It doesn't matter. Because now, where's the list of tools? So we done strings, MD5, the checksum is important. FTK, that's commit. But now, let's use sleuthkit and autopsy and foremost. Now, it's time to introduce you to sleuthkit and autopsy and foremost. We've done DD already. Let's now analyze that DMG evidence.dmg file. Yeah, I'm thinking about, I mean, I totally won't blame you about Windows. Now, what is autopsy? I like to explain it to people this way. If you can't afford NCase, there is sleuthkit and autopsy, which is free and open source. Autopsy is a graphic user interface program, platform independent. Doesn't matter if you have Windows, Linux, Mac, doesn't matter. sleuthkit is, really think about it this way, the back end. Collection of command line tools and C libraries to analyze disks and recover files in them. It's used behind the scene in autopsy and many other open source commercial forensic tools. Is it modern? Oh yeah, absolutely it is. Also obligatory, speaking of cracking phones and stuff. Did anyone read the recent article on Signal? How they actually took advantage of Celebrite? Really good read. So, sleuthkit and autopsy go hand in hand. Okay, autopsy is a graphical user interface program. sleuthkit is really the back end that powers autopsy with command line tools and all that fun stuff. There is a version, an older version on Kali Linux, which I'll show you now. So, here we are. Okay, here is Kali Linux. Let's take a look at the menu, and there are forensics tools. I see autopsy here. Cool. So I'm going to clear my screen, autopsy. Autopsy is a forensics browser. Autopsy forensic browser. By default, autopsy starts a forensic browser served on port 9999, and oh damn, there's a typo. And accepts from localhost. Okay? So, I also want to let you know that I made a copy of that evidence.dmg file under workspace. So the MD5 checksum of the evidence.dmg file is 2cc8b. Does that look similar to what we got that we calculated earlier in the Mac? Yep, there we go. 2cc818. So okay, the evidence is intact. Same hash value that's being used. So now let's try to uncover all the deleted files and any other files in evidence.dmg using autopsy. Now clear the screen, and really what you need to do is sudo autopsy. Hey! The autopsy forensics browser. Open up an HTML web browser and on a remote host and use this URL. Okay, I'm going to copy that link. I'm going to open up a web browser. There we go. Nice. Your web browser has JavaScript enabled. You do not need JavaScript to use autopsy, and is recommended to be turned off for security reasons. Yay! This is a really old version of autopsy, but it works. So now we're going to create a brand new case. We're going to call this Twitch 2021-0422. We're going to give a description. We're going to do Gabman15 as one of the investigators' names, optional. So we're going to add Gabman15 as an investigator. We'll actually also have 31337 H4XORM4M. And we're going to have is Mr. Bean Dumble. I think that's it. We got 4 people on the air. High IQ Andy. Yeah, sure. Yeah, we'll add Buggles too. Bugles. Bugless 21. Bugles. Alright, well, we got 5 investigators on this case. What? Bugless 21. Okay, I think I spelled it right. I'm going to hit a brand new case now. Alright, create case. Please select your name from the list. Okay, we're going to say whatever. We must now create a host for this case. Man. Host, I don't know. Okay, we can just leave everything blank. Path of alert hash. Ooh, this is important. An optional hash database of known bad files. Now, this actually is important. I'll give you an example of what this means. Path of alert hash database. So, I know if you're doing investigation for, let's say, child pornography, there's a well-known hash database of like bad pictures. So if, pictures that actually have a different hash, that have already hash values, so you want to put that on here. That is actually how also companies like Dropbox, they investigate. They can tell if you're uploading illegal material or copyrighted material onto Dropbox by having an alert hash database. There's also an ignore database too. Known good files, don't touch them at all. Fine, we're going to add a host. We got nothing to add. Adding host. Now we must import an image file for this host. Now the image file we're going to use for this host is going to be on my directory inside of a folder called workspace. So if I do a pwd is /home/defcon/workspace/evidence.dmg. Let's do that. So I'm going to add an image file. The full location is home.defcon/workspace/evidence.dmg. And I think we got it all correct. And select this type. This is a disk. Now, if you want to import the disk, there's a couple of ways. One is to analyze a disk file image. It must be located in the evidence locker. You can either make a symlink, also known as a shortcut to the file, or a direct copy to it. If your disk is like 40, 50 gigabytes, you don't want to make a copy of that stuff. You want to make a shortcut to that 40 gigabyte file. Because if you do a copy, it's going to make another 40 gigabyte copy of that disk. You don't want that. Let's do symlink. Is it possible to change the hash? Yeah, if you tamper with the evidence, like open it up, add a file, do something to it, then do a DD on it again. Let's do this. Evidence, data integrity. An MD5 hash can be used to verify the integrity of the image. Let's calculate the hash image for this value. Let's do that. File system details to see all this information. Yeah, let's do that. Keep it at that, but we'll calculate the hash value for this image. And you can see that the MD5 hash is 2cc, yada, yada, yada. It's too small to read, but yeah, it looks good. Okay, we're done. Here we are. Here we are, folks. So now we got our case opened. We have not one but 2 mount partitions that we can investigate. So let's actually do an analyze of the evidence.dmg.dish. Let's try to analyze that. See if there's anything interesting that we can find. To start analyzing this volume, choose an analysis mode from the above tabs. You can do a keyword search. There's predefined searches to look for social security numbers, date, credit card numbers, IP addresses. There's also image details. The problem with this file analysis right now is file type metadata are all blanked out. Image details, that's it. There's nothing good here. Let's close that. Let's try to analyze the C file though, C:/ evidence at 2048. Interesting. Let's see the details. Oh, nothing there. What's this one though? There's FAT16. You want to extract the strings? Extract strings of the entire volume. Extract ASCII and Unicode strings from a file system will make keyword searching faster. Yeah, why not? Nice. Now, let's go to image details. Let's close this, and let's do an analyze of the amount, the C:/, that's the C drive. Now it gets interesting. File analysis tab is now open. So is an image details. Here's the stuff about the image details. FAT16. You can see all the disk information here. But the real interesting stuff is the file analysis tab. Boom. This is the view that you can actually see all the files that are on the disk. Anyone want to take a wild guess what the red color means? Anyone want to take a wild? You got a problem here. Remember this picture that you saw earlier on? This WebP, the one with Bikini Bottom Twitter? That's in blue. This is the picture. There's also a text file here, stack.txt. It's the smashing the stack for fun and profit. Those are the two files that we saw on the disk, on the Mac. But now, using a tool like Autopsy and SleuthKit, we can also uncover the deleted files as well too, that are marked in the red. There's a lot more pictures than you think. Now let me click on one of the red pictures. Did you see that on the disk? That picture? I don't remember that one that we saw on the disk. The hell is this file? The art of exploitation. This I don't remember either. On Frack, I don't remember seeing this one. What's this one? All the red files are deleted files. We have now just uncovered quite a lot of deleted files. I'm going to close this disk out. I'm going to close this case. Something is definitely up with that evidence.dmg file that we've been looking at. is there a way now to just extract all the deleted files off of evidence.dmg? And the answer is yes. And this is where we're going to use Foremost. So what Foremost is one of my favorite tools because it just works great. Foremost was also built at the Department of Defense. So if you're curious what DC3 stands for, the DC3 is the Department of Defense Cyber Crime Center. I always forget the acronym of what DC3 says. So the Department of Defense Cyber Crime Center, which was, if I'm not mistaken, was it was run by Jim Christie for a number of years, and he's a friend of mine, and I want to give a shout out to Jim Christie for running this organization for years. And Cybercrime Center at the Department of Defense have created a lot of different tools, and one of them is Foremost. One of my absolute favorites is Foremost. Foremost, what it does is does something called file carving and recovery. So it'll take a disk, like a DMG file, or an IM. It doesn't matter what kind of a disk it is. ISO, DMG, DD file, doesn't matter. Reads all the header and footer, reads all the data structures, and just rip out all the different kinds of files from the DMG file. So for example, if you want to just rip out all the JPEGs in a disk, here's your command. Foremost minus S, 100 minus the type is JPEG minus I, the name of the image. Okay, so now we're going to do this. We're going to use Foremost now. Foremost recover files using their headers, footers, and data structures. Recover files from a disk image based on file type specified by the user using the minus T switch, which is a type. JPEG, GIF, PNG. There's so many different types of files that you can just rip out from a disk image. CPP file, MP4 file, all. So I'm going to do Foremost minus S 100 because we're going to skip the first 100 bytes. Oh, wait a minute. Is it 100 bytes or 100 blocks? I don't remember. 100 blocks. I'm going to be careful with my terminology. Minus T, we're going to rip out all the JPEGs. First, minus I is going to be evidence.dmg. And what we'll do, process all the evidence. There you go. Done. Output. Ooh, there is an audit.txt file. 3 JPEGs got recovered from evidence.jpg. 46 kilobyte, 98 kilobyte, 125 kilobyte, 63 kilobyte, 80 kilobyte. 5 JPEGs were in evidence.dmg. Can we see what they are? Sure can. That's 1. That's 2. That's 3. That's 4. That's 5. That's 5 JPEGs recovered from evidence.dmg. If you're thinking this is some magic trick or something, well, no, because first of all, remember we calculated the hash values of the disk, so it was consistent across the board. Whether it was on a Mac, whether it's on the Kali Linux, the hash value was consistent across the board. No magic trick here. It's just a whole bunch of files that got deleted using RM, but when you use RM, file is not deleted. Okay, let's go back. Close this window. Yep. Alright, let's go back. Let's go back up in, let's say, PNG. Let's start from the beginning again. Let me remove the output folder. Go back up, but I want to recover all of the PNG files. Yeah, that's a great question. What's the second half of a deleted file is overwritten in memory? Can it still recover partial file? The answer is yes, it should. Yeah, absolutely. It should recover the partial file, even if it's well. That's the thing about tools like Ncase, Autopsy, Salute Kit, Foremost, you name it. It can also work to recover corrupted files. PNG. Are there any PNG files? Yeah, there's only one PNG file got recovered. Really? There was one PNG file in that thing? Take a look. Boom. Sure thing. I mean, this one is just a whole bunch of files just got removed by RM. But if it got even corrupted files, I mean, tools like tools like Foremost, Salute Kit, yeah, they definitely can recover them. That's a really good question by 3133 Hexor Man. Yes. Yeah, it can recover partial file. And that's a big problem in forensics when you had to deal with corrupted files. Big problem. What are the forensics tools I hear? I never really known. Binwalk, Foremost, Hashdeep, Yara. Yeah. I got five. Oh, there's Scalpel. I haven't used for so long. There's PF, PDF forensics tools, and the Sleuth Kit suite. Yeah. Whole bunch of different tools here. I mean, the only other thing I just want to mention just briefly is, I need this. Oh, there's this tool called Vignetto, which actually extracts information from thumbs.db files if you're on Windows. This was old on cracking web and Wi-Fi networks. So old. Fun times. Well, so what's the difference between forensics and incident handling? Incident handling is called IH. It's just the whole logistics of communications. In order to resolve an incident in a calm and effective manner, so you don't keep on barking up the wrong trees. Incident response is all the technical components required to analyze and contain an incident. So incident handling is a really broad term. Incident handling is important because it's like, legal issues, barking up the wrong tree. You don't want to get into dead end investigation. Organization, like who to contact, is important. So what's the difference between incidents and incident handling and forensics? Forensics is really answering the questions of who, what, when, where, why. Like backtrack and see what really happened. Incident handling is you got to be well versed with many different facets of information technology and IT. So it goes way beyond just who, what, when, where, why. Think of it this way as a big triangle cone. Instant handling is that broad spectrum. For forensics, it's like the tip where you have to answer, you have to be very specific and very, very concrete on how the information is stored, where was it stored, who created it, yada, yada, yada. Instant handling, 6 phases: preparation and identification, containment, eradication, recovery, and lessons learned. If you really wanted to take the incident handling course, take SANS SEC 504 Hacker Tool Techniques, Exploits, and Incident Handling, which I am an alum of. So you learn a little bit about forensics, a little bit, but you learn the whole process of okay, who if you want to call law enforcement to help for a case, and other stuff. And that's it. That's all I got. Oh, the other like, how do you fight against forensics? Full disk wipe. Um, you learn that using tools like RM never gonna remove a file completely. So if you want to do something called a full disk wipe, or like that's called DOD 5220.22-M. It's a Department of Defense standard to how to securely remove wipe disk. Remove logs. Use steganography to hide pictures inside of different files or hide files inside different files. They use encryption. And, well, I guess that. So if you want to guarantee a file is deleted, what do you have to do? Take a hammer and drive? Well, I guess we'll just end the conversation. We'll just end the call here. We'll just end tonight. We'll just end the session with the biggest message of them all. So if you want to guarantee that a file is deleted, what do you have to do? Take a hammer and say, yeah, put it in the barbecue pit or fire pit. That's it. Mm-hmm. Not just a nail. Don't just do a hammer and a drive. Barbecue pit, fire, let it burn. And perhaps that's the best way to end today. That's it. That's all I got. And next week, one last talk. Yeah. Yeah. That was a really good question to end it all, and you played into the, yeah. I mean, they can not just a hammer to the drive, that put it in the barbecue pit. Um, yeah, barbecue fire. All right, I'm gonna stop the streaming now. See ya, folks. Have a great day and a great week.